Hi everyone, Prof. Chris here. In this presentation, we will be covering Chapter 5.6, Ratios and Rates from the OpenStax Pre-Algebra textbook. Now, our core learning objectives for this particular presentation is to write a ratio as a fraction, write a rate as a fraction, find unit rates and unit prices, and then finally translate phrases to expressions with fractions. So let's get started with this first initial question then, to define what actually is a ratio, and then how we might describe the following image as a ratio below. So go ahead and pause the video here and see if you can answer these two questions for me. Okay, so to start with this first question here, what is a ratio? A ratio is a comparison of two quantities using division, often structured in a fraction form. Now, if I look at the bottom image here and how we might describe this as a ratio, what we have here is green squares and yellow squares. So we are going to describe this image in a ratio form here. So what I see on the left-hand side is a total of 1, 2, 3, 4, 5 green squares. And then on the left or the right side, 3 yellow squares. So we could write this as 5 green squares, 2, 3 yellow squares. Now, I could write this ratio as a fraction. You can also write this ratio in terms of a colon. So I could write this as 5 colon 3. Or I could write it with words, 5 to 3, or 5 per 3. So there are several different ways a ratio can actually be written here. Now let's look at writing a ratio as a fraction. So we're going to first look with some whole numbers here. And how we write it as a fraction is we first are going to take the number that's on the left side of the ratio, 20, and put into the numerator of our fraction, and then the number that's on the right side and put it into the denominator of our fraction. Then we will look to simplify this fraction. So when we are simplifying, we're dividing out a common factor here. So a common factor of 20 and 25 then is the number 5. So I can divide the top and the bottom number by a factor of 5 here. So 20 divided by 5 is 4, and 25 divided by 5 is 5. Now 4/5 cannot be simplified any further, so question number 1, the ratio is going to be 4/5 here. Looking at question 2 now, we have 72 to 30, so 72 is going to go into the numerator of our fraction. 30, that's on the right side, will go into the denominator. Then we are going to simplify the fraction. So you might notice first that these are even numbers. So if you want to start with smaller factors first, I could divide both the top and the bottom by a factor of 2. And what we end up getting here then is 36 over 15. Then you might recognize, there's another number that you can divide into 36 and 15, and that happens to be a number 3. So 36 divided by 3 and 15 divided by 3 also simplifies down. 36 divided by 3 then is the number 12. 15 divided by 3 is the number 5. Now, if you wanted to, you could also simplify these two numbers down by a bigger number, or the greatest common factor. So if you look at 2 and 3 here, these are two individual factors. If I multiplied those two factors against each other, 2 times 3, we get the factor 6. That is the greatest common factor for this problem. So if I simplified down by 6 at the beginning, 72 divided by 6 is 12, and 30 divided by 6 is 5, you can do this factor, or this simplification step in one fell swoop. Now let's look at writing a ratio as a fraction with decimals. So the initial steps are the same in that we look at our question when we first write it as a fraction. So we're going to write 2.4 over 3.6 here. Now, what we need to do is we need to rewrite as an equivalent fraction without decimals. In other words, we're writing these now as whole numbers. So to do that, we're actually moving our decimal point. So in this case, I'm moving my decimal point to the right 1 and to the right 1. In other words, every time you move a decimal point, you are actually multiplying by a factor of 10. So if I multiply 2.4 times 10, and then I need to multiply the same thing to the bottom part of the fraction, 3.6 times 10, I get 24, and I get 36. Okay, so that is our new fraction here. So I can now take 24 and 36, and I can simplify it down. So again, I could simplify it in smaller chunks. So let's say you wanted to do it in small factors first. 24 and 36, you can divide by a factor of 2 and 2, which becomes equal to 12 over 18. Then you might recognize that can be simplified by another even number, factor of 2 as well. Or you might even know another number at this point, which is going to be 6 and 9. And then you could factor by a 3 here, 6 divided by 3 and 9 divided by 3. So 6 divided by 3 is 2, and 9 divided by 3 is 3. So you get 2/3. So 2/3 is the simplified version. Now again, that's not our greatest common factor. If you were to look at the factors here now that you divided by 2, 2, and 3, if you multiplied those numbers against each other, which these are all prime numbers, that's the other thing is you could do this prime factorization tree to see what the similar factors are. But you might notice that if I multiply 2 times 2, that is 4 times another 3, which is 12. So the greatest common factor then for 24 and 36 is actually a factor of 12 here. So 24 divided by 12 is 2. 36 divided by, that's a 12, badly written. I'll try to clarify that a bit more, which is 2/3. Okay? So that's question 1. Going to question 2, we're going to start the same in that we have 1.8 and we have that over 0.45. Now, when we actually change these to whole numbers, we need to move our decimal point the amount of times it takes for both of these to be whole numbers. So because this 0.45 is 2 movements away from being a whole number, I need to move that 2 places to the right, in other words. So I'm moving it once and twice. Now, every place movement you move is a factor of 10. So if I do 0.45 times 10, I would get 4.5. If I do 0.45 times 100, you get 45. So that's what I'm actually going to do. I'm going to multiply this by 100. Now, to keep an equivalent fraction, I need to multiply the same factor in both the bottom and the top part of the fraction. So even though I only need to really move this over once to make it a fraction, I want this to, or to make it a whole number, I should say, I want this to be an equivalent fraction. So I actually need to move it over 2 times, the same amount as I did in the bottom, or multiply this by a factor of 100. So then what I would end up getting is 18 over 45 here. Sorry, I forgot what the extra 0. I get 180 over 45, I should say. Apologies for that. Okay. So now what we have here is we have 180 over 45. And now what we're going to do is simplify it. So you could start small if you wanted to again. So 180 and 45, you might notice that they both end in 0 and 5. So I can divide a factor of 5 into both the top and the bottom. And what I end up getting is 180 divided by 5 is 36. And 45 divided by 5 is 9. Then you might recognize that 36 over 9. I could factor it further, 3, but you might also recognize something interesting here. Isn't 9 a factor of 36? It is, right? It divides in evenly. So in reality, I'd probably just go ahead and go there, even though you could go smaller. You could do a 3 and then another 3. But at this case, because these are whole numbers, or 9 divides evenly into 36, we can do that, and what we end up getting then is 36 divided by 9 is 4, and 9 divided by 9 is 1. So we get 4 over 1, which could actually be just simplified to a regular whole number, 4. Now, usually structuring that, this is a more formal way of writing a ratio, 4 over 1, but this is as far as you can simplify it down. Now, again, if you wanted to use the greatest common factor for 180 and 45, you might recognize that 9 times 5 equals 45. So you could theoretically divide both the top and the bottom parts of the fraction by a factor of 45, and this would get you 4 over 1 again, or just equal to 4. Okay, so that is writing a ratio as a fraction that has decimals in it. Next, let's write a ratio as a fraction with mixed fractions. Starting with question number 1, we have 1 and 1/2, 2, 2 and 1/4. So we're going to write this as a complex fraction, meaning we will have a fraction in the numerator, 1 1/2, followed by a long fraction bar, and then a fraction in the denominator, 2 and 1/4. The second step is to convert the numerator and denominator to improper fractions. In other words, convert 1 1/2 to an improper fraction. So this would become 1 times 2 is 2, plus the 1 is 3. So 3 is the numerator and 2 is the denominator. So 1 and 1/2 converts to 3 over 2. And then we will change 2 and 1/4 to an improper fraction. 2 times 4 is 8. 8 plus 1 is 9. Over the denominator 4. From here, then, we will rewrite as division of fractions. So instead of a complex fraction, we're going to write as a horizontal division problem. The numerator 3 over 2 is the left side fraction. The long division bar just becomes a regular division symbol, and then we have 9 over 4. Okay, so from this case, we're going to invert the divisor and multiply. In other words, this is that keep it, change it, flip it rule we talked about in a previous video. So we will multiply 9 over 4, or excuse me, we're going to change to multiply and then flip over 9 over 4 to 4 over 9 and multiply that. So it will become 3 over 2 times 4 over 9. In other words, we keep 3 over 2, we change division to multiplication, and we flip 9 over 4 to 4 over 9. Then we will go ahead and multiply. First, I like to see if we can cross-reduce by division. So we look for a common factor and we look diagonally, so cross-reduce. So 3 and 9 can be reduced down. 2 and 4 can also be reduced down. So I could divide a 3 into 3, and a 9 into 3, or 3 into 9, I should say, and a 2 into 2, and a 2 into 4. So then rewriting my new fraction, we'd have 3 over 3 is 1, 2 divided by 2 is 1, times 4 divided by 2 is 2, 9 divided by 3 is 3. Then we can multiply across. 1 times 2 is 2, and 1 times 3 is 3. So we get the fraction 2 over 3 here as our final result. Let's look at question 2. So again, we will write 2 and 1/3 in the numerator of a complex fraction and 3 1/2 in the denominator of the complex fraction. We will then change to improper fractions. So 2 and 1/3 changes to 2 times 3 is 6, plus the 1 is 7, over 3, divided by 3 times 2 is 6, plus 1 is 7, and the denominator is 2. So now we have 7 over 3, long division bar, 7 over 2. Let's now rewrite as division of fractions. So 7 over 3 is the left side fraction, division sign, and 7 over 2. We will then invert the divisor. That's the 7 over 2, which is to find the reciprocal or flip it. So this is that keep it, change it, flip it rule. 7 over 3 stays 7 over 3. Division changes to multiplication. 7 over 2 changes to 2 over 7. From here, I like to cross-reduce if we can. So we can look diagonally, 7 and 7, we can reduce by 7. But 3 and 2, we cannot. Sorry, this is a 7. So rewriting our fractions, we now have 1 over 3 times 2 over 1. Then we can multiply. 1 times 2 is 2, 3 times 1 is 2, or 3, and we get 2/3. Which seems very similar to the previous. Okay, so that is our answer for question number 2 as well. Next, let's write ratios of two measurements in different units. So starting with question number 1, we have 24 inches is to 1 foot. So we write this as a fraction. Next, we will convert this to the same unit here. So we could either change it from inches to feet or from feet to inches. So let's go ahead and change to inches though. So that means we look at the conversion factor for 1 foot to inches, and the conversion factor for this is 1 foot is equivalent to 12 inches here. So converting this, I am basically going to multiply 1 foot times 12, and what we end up getting is 12 inches. So in reality, this is going to be 12 inches is to 24 inches in this case. That's the ratio that we're looking at. From here then, we are going to simplify our two, our fraction here. So to simplify this, we can divide this down by 12, and we can divide this down by 12. And what we end up getting here then is 24 divided by 12 is 2 inches. 12 divided by 12 is 1, so we get 1 inch. So in other words, this particular ratio that we have is going to be 2 inches is equal or equivalent to 1 inch for the ratio. Okay, let's look at question 2. So in this case, we have 1 foot to 48 inches. So again, I'm going to convert to the same unit, which means I again use the conversion factor of 1 foot to 12 inches. So I would multiply 1 foot times 12 to get to 12. So now my ratio would look like this. We would have 12 inches on top, and we have 48 inches on the bottom. Now we're going to simplify this ratio. And again, with this one, we can divide by that factor of 12 here. So in this case, what we end up getting is 1 inch. So our top ratio, and 48 divided by 12 is 4 inches on bottom. Okay, so that's the ratio that we would have if I was to have a ratio of 1 foot to 48 inches in whatever context that might be used. Now we will write a rate as a fraction here. So a rate compares two quantities of different units, like calories and ounces in question 1. Now a rate, like a ratio, is usually written as a fraction. And when writing as a fraction, we put the first given amount with its units in the numerator, and the second amount with its units in the denominator. And then when the rates are simplified, the units remain in the numerator and denominator. So let's start with question 1 here. 180 calories, I'll put that as cal, over 15 ounces. Okay, so now we have written as a fraction. Next, we will simplify this fraction. In this case, 15 goes into both 15 and 180. So I can divide by a larger number. The greatest common factor in this case is going to be 15. So 180 divided by 15 is 12, and 15 divided by 15 is 1. Now rewriting this a bit clearer then, we would have 12 calories is found in 1 ounce here. Again, our units remained in the numerator and the denominator for our rate. The next question then we have is $480 for 30 hours. So let's put 480 in our numerator here. And, oh, that's dollars, sorry. And then we will put 30 hours in our denominator. And then we're going to go ahead and divide. So let's say we divide it in chunks here instead of the greatest common factor, because in this case, I'll write it down here to give us more room. In this case, we can quite clearly see that this is divisible by 10 to start, right? So I could divide by 10 here and divide by 10 here. And then what I end up getting is 48 over 3 to start. Then I can notice that 48 and 3 can be divided down by a factor of 3. So 3 goes into 3, obviously, and 3 does go into 48. So 48 divided by 3 is 16, and 3 divided by 3 is 1. So I have $16 for 1 hour. So this could be an hourly rate of pay, for example, as a rate. The next series of questions then deal with unit rates. Now a unit rate has a 1 in the denominator. So our initial steps though are the same. We're going to go ahead and write our statement as a rate. So we have $425 in our numerator, and then we have 18 hours in our denominator. Now, how we do this then is we are actually dividing the numerator by the denominator. So 425 divided by 18. So 425 divided by 18 is an irrational decimal. You get something like 23.61111 ... Now, since this is money, we're talking about money here, really we're rounding to the hundreds place, right? So rounding this to the hundreds place, we will get 61 cents here. Okay, so how we would end up writing this then is $23.61 over 1 hour of work. Okay, so that is our unit rate here. Question 2 then, we have 36 beats, so maybe we're talking about music, maybe we're talking about our heartbeat, I guess. So 36 beats in 0.4 minutes. Now again with this, what you can do is you can simply divide the numerator by the denominator here. So 36 divided by 0.4. And what you end up getting here is a whole number, 90. So we actually get 90 beats in 1 overall minute here. Okay, so that is the concept of a unit rate. Now, similar to unit rate, you have a unit price. So this is often what occurs when you go to a store. Maybe you're running a business and you have to figure out what your inventory is and the unit price you have for each item of inventory, right? So step 1, we have soap bars at 4 for $6. So we have 4 soap bars at $6. Now, what we do with unit prices, that's a little different than previous, is you're going to put the money in the top part always of the unit price, so $6, and the actual product then for soap bars in the denominator here. So at this point then what you're going to do is you're going to go ahead and divide 6 divided by 4, which 6 divided by 4 is $1.50. So we get $1.50 per soap bar. Okay. So that is our unit price for question 1. Question 2 then is the grocery store charges $5.40 for a case of 24 juice boxes. So again, our money, our unit, our price goes in top, even though it's a smaller number than 24 in this case. So we have $5.40, and we have a 24 juice boxes. So I'll just say 24 juice in this case. So what is the unit price here of one juice box? Well, we're going to divide $5.40 divided by 24. And when we do that, we get a decimal 0.225. Now, we're talking about money here. We want money, so we actually have to round up to the nearest hundredths. So we're looking at the 2 in the hundredths place, and we're looking after that, which is 5 in the thousandths place. So we're going to round this up to 23 cents. So how we would write this then is 23 cents is the unit price per juice box. I'll say JB for juice box. Okay. So that is the unit price then for question 2 here. Round to the nearest penny as a result. The final concept for this presentation is to translate the word phrase into an algebraic expression. So we're going to write each of these word phrases as a rate structure here. So question 1, we have 550 miles per h hours. So the 550 miles, that is the first measurement unit. That will go in the numerator of the fraction. Then we have the word per. This signifies that we're working with a ratio or rate. And then finally we have h hours. That is the second measurement unit, part of the rate or ratio. That will go in the denominator. So then writing this out as a rate, we would have 550 miles over or per h hours. Now we can't simplify this fraction because the 550 and h do not have a like term, so this is as simplified as you can go. Question 2 then, similarly, we have 150 calories as our first measurement unit. The word in this case represents our ratio, so this signifies that we're working with a ratio. And then finally, x ounces is the second measurement unit that's in the denominator. So then how we would write this out is we would have 150 calories in our numerator over x ounces in our denominator here. Okay, so that signifies the end of our presentation. In this presentation, we covered Chapter 5.6, Ratios and Rates. That's in the OpenStax and Pre-Algebra textbook. The learning objectives we then looked at were to write a ratio as a fraction and a rate as a fraction. We then looked at finding unit rates and unit prices. And then finally, we looked at translating phrases to algebraic expressions, specifically in rate form. So I would go ahead and get into the OpenStax chapter, work on a few of those questions. If you have any questions, feel free to drop it in the comments below the video. You can find the link to this chapter also in the description below. So good luck everyone, and I will see you in the next video.